So,
Yeah.
is it always 95% only?
Why? Again, same question, yeah, as yesterday. Whatever confidence you want to use, you can apply.
So it's not 2.5 only, right? Depending on what they give.
Of course, yeah. If you want 99% confidence, then apply whatever, 0.5% on one side and 0.5% on the other side. Yeah. Okay. Cool. So what we'll do now is the following. I will send you some. I'm sharing with you a file. I've shared a file with you guys on chat. Would you be able to, can you see if you're able to access it, please?
It's in Zoom chat, sir.
It's in the Zoom chat, yes.
Does not come yet.
I can't see.
No,
actually.
What did come?
Has it come through or?
Not yet.
No, no.
Not yet. No, it's not come.
No?
Yeah, it's here.
Yeah.
Now?
No. Yes.
Okay.
Yes.
Can you just download that and keep it with you? We will use that now. No. Is everybody able to see my screen?
Yes. Yes.
Now, these are broadly the, so what are these reading times? So somebody has an app, it's a news app, right? And these are the amounts of time that males and females are spending time reading on that app. Is everybody okay with that?
Yes.
Okay, so broadly what they're saying is that, that in this particular instance, the cell that I've highlighted, this particular female reader spends 42 minutes on that app per day. Okay, it's a newspaper app. Okay, and these are the reading times. And then similarly, we have been given data for all of we've drawn a sample, and what we've been given are reading times for males and females. Is that okay?
Yes.
Okay. Now, what we are claiming here is, can I do some hypothesis tests on this particular data? Okay. Is everybody okay with that?
Yes.
Any questions on the data that's been shared? Is broadly everybody okay with?
The number of population pool between female and male is different.
That is okay. It makes no difference to me.
Okay.
Okay, so yeah, so my sample sizes for males and females can be different. Wasn't that true in that confidence interval example?
Yeah.
In the confidence interval example that we built, where we were looking at credit card spend between males and females, I had 225 females and only 190 males or something like that, right?
Correct, yeah.
Right. So yeah, so there's no necessity for when I'm comparing two populations.
Okay.
Like in this case, I'm comparing males with females. There's no necessity to have the same sample size.
Okay.
Because when I do that sigma over root n business, it takes care of the fact that my population sizes are different, right? I'm not using the fact that look, they are the same. Okay.
Okay.
So in this particular instance, what I'm going to ask you to do is to find the average of female reading time and the average of male reading time. Can you guys do that for me? This is average female reading time. So the average of
That's 42.146.
for these numbers. Okay.
Male, it is 45.31.
And average for male is
45.31.
45.31.
so. Oh, 45.31, right? So, can you guys, for example, suppose the newspaper app company, right, claims that the following, that females on average, mu F on average is 44. Suppose the newspaper company claims that on average females spend 44 minutes on the app. How would you test that claim? Anyone?
Basic
null
pi-
hypothesis
Calculate the
is
variance.
Yeah, I would need the sample standard deviation, of course. Yeah, so
Yeah, standard deviation.
yeah, that's fine. But what is when I say how do you test this claim, what am I asking you to set up?
Mu
Null
null hypothesis is
hypothesis.
equal to 44.
So
No,
I'm
no.
asking you to set up a hypothesis test, right? So the hypothesis test will look like what? It'll look like H0 is
44.
44.
mu
44.
mu F equals 44, correct?
One is not equal to 40.
The alternate will say
not
mu F not equal to 44, or you could set up the one tail test with,
Less than.
less than
you will set up the left tail test with mu F
Less than 44.
less than 44. Why less than?
Because
Average is 42.
Average is
Exactly.
less
Because my sample average is less than 44. Correct. Exactly. And then what? I will calculate what? T calculated is what?
We can use the normal distribution also.
No, I don't know the population standard deviation.
Okay.
I don't know what is the standard deviation for the overall population. I can't use that. So what is my T calculated will be? X
T
bar
cal-
minus mu
by
divided by S over
root of
Sample
n.
size, root of n.
root of n.
Root
Okay.
n.
So I need to know what is S and what is N. I already know what is X bar, what is mu.
Yeah.
What is my sample standard deviation?
3.43.
This is standard deviation for
Three,
females. What is it?
3.14,
My sample standard deviation.
3.43.
Is that right? Let's see. What am I getting? 3.44 is what I'm getting, right?
Mhm.
Okay. And my standard deviation for males is
6.1.
how much is that?
6.17.
Okay. Yeah, 6.17. Correct. So what is N?
Count.
What is N for females? How many observations are there in my female data set?
126.
126, yeah.
Yeah, 126. Yeah.
And what is my sample size for?
46.
46.
46. Perfect. Now, do I know all values in my T calculated calculation?
Yes.
X bar minus mu S over root n. Can you guys tell me what that value is then? Absolute value, let's say. I don't have to be confused about numbers, right? So what is this value?
0.04.
How much is this turning out to be?
.04.
Is that right? Can someone verify that? Is it that high?
6.06. Yeah, 6.06.
What is T critical? What is my sample size?
126.
126. 126 at a 95% confidence level. If my sample size is more than 30, T distribution is almost the same as
No.
normal distribution. So what will be the T critical value? 1 point?
1.96.
No. 110 test.
T
Remember I'm
by
looking at?
T by
1.64.
0.05,
Five.
125.
Yeah. How much is that? Somebody said 0.05 and 125. How much is that value for T dot in?
Just
1.6.
1.65, right? Approximately the same as 1.64, give or take.
Yes.
Yeah. So, and what is my hypothesis test going to say now? T calculated is
Greater than.
more than
Then T critical.
T critical. Therefore,
Reject the claim.
reject the null. Yeah, exactly. Implies what? Reject null. What are they claiming now? What was the null claim?
44 minutes reading
Time
time.
was
44 minutes. They are clearly overestimating how much time people are spending on their app. Our sample was showing 42.14. These guys were claiming 44. Clearly, they are overselling themselves. Okay, so you will reject the claim that females on average spend 44 minutes on the app.
Yeah.
Okay.
Sir, where did we get this value 44 from? It is given in the question.
Yeah, it's given in the question. Exactly. Right. So the question
Average
says,
reading value.
yeah, the company is claiming that female users on average spend 44 minutes reading on their app. And what we have now proved statistically is that their claim is factually incorrect. We've rejected their claim based on the data that was collected. Okay. Is everybody okay with this?
Yes.
Yes.
Okay. Any questions on this example? Because if we know how to do hypothesis testing for one population, I can now move towards the next one. The one where I'm starting to compare two populations. Okay, I have reading times for females and reading times for males, remember? Now the company claims that males and females on average spend the same time. That our male users and our female users spend exactly the
Same time.
same time. So what is that null hypothesis there? Remember, this is a different case. What am I claiming? In this case, my null hypothesis is what?
UF is equal
Distribution is minus is 0.
What is my null hypothesis? That mu male
Is equal to
Minus.
to mu F.
Mu F.
equal to mu female.
Yes.
Okay. Everybody okay with this? This is different, right? So now I need,
Yes.
we have not done this, right? This is a test to compare
The reading
what?
time.
Two
I'm comparing averages of two different populations, right? Where the null says that the average of population 1 is exactly equal to the average of population 2. Okay, so to do this, instead of doing it by paper and pen because the formulae get complicated, let's move to our data analysis tab. Okay, so if I go to data in Excel and data analysis,
Okay.
guys, does everybody have this with you?
Yes.
Yes. Yes.
Okay. If you do this, you scroll all the way down to the bottom. Do you see those paired two sample for means, those t-tests? You're seeing
Yes.
all those values of those t-tests, right? So it says two sample assuming equal variances, two samples assuming unequal variances, and so on. Right.
Sir, I don't see data analysis tab in my Excel. Is it that any particular
Yeah.
version?
Options में जाके you have to check the solver.
No, 1 second. It's in
It's
your
an
data
add-on.
ribbon. Hold on, guys. If you go to the data ribbon, it should be on your extreme right side.
It usually isn't there, sir. Not
I
for
have
everyone.
option till outline actually. I don't have data analysis.
It's an add-on, sir. It's an add-on.
So it's an add-on, yeah. So you need to add it on, yeah. We did this in the last class, remember guys? We've done this in our own course, right? So go to Excel add-ins and add data analysis and the solver add-ins. Okay, so now if you have this with you, then what I'm asking you to do is to look at the bottom of those data analysis tool packs, right? You have the t-tests here. Everybody okay with that?
Right, yes.
Yes.
Now, the first thing is when I start to compare which t-test should I use here? There are 3 of them. Right? There's a paired 2 sample for means, there is a sample assuming equal variances, there is a sample assuming unequal variances. Okay, so we leave the paired test for a bit. I need to first figure out whether I need to use the t-test assuming equal variance or the t-test assuming
Unequal variance.
unequal variance. Okay, I need to figure out which one to use. So for that, I need to figure out whether the 2 populations actually have an equal variance or an unequal variance. Is everybody okay with me so far?
Yes.
Yeah.
Yes.
So I have to first figure out whether the population variances between males and females, whether they are equal or they are unequal.
Unequal.
Okay, so to do that, I have to do another test first. Okay, so if you go to the top, do you see this F test, which is called 2 sample for variances?
Yes.
Yeah.
Hmm.
You see the test called the F test, which is the 2 sample for
Variance.
variances. Okay, so now what happens there is that particular statistical test will tell me whether the variance of males is equal to the variance of females, yes or no. Is everybody okay with the logic that
Yes.
I'm using?
Yes.
Yes, yes.
Okay, and once I figure out that the variances are either equal or unequal, then I can go and choose the appropriate t-test.
T-test.
Hmm.
Okay.
Hmm.
Right, so we have a 2-step process here. When I'm comparing means of 2 different populations, I first have to figure out whether their variances are equal or unequal. Once I figure out that their variances are either equal or unequal, then I will go and choose the appropriate t-test. Okay. Now to do this, let's do the F test first then. Okay, I click OK.
Hmm.
Okay, before I get there. Folks, how many of you are with me? Can I get a thumbs up sign on your reactions just so I can see? I am failing at a 95% confidence, folks. Our t-test is statistically insignificant. Okay, I'm seeing only 60% of our thumbs up.
Mhm.
Nah, 40% no thumbs up. Okay, so see, this is exactly where being in class helps.
Correct.
Because you could have paired up with your neighbor, right? You could have looked through someone else's shoulder and so on. So now you're left alone on a floating island. Water everywhere, and all the boats did shrink. Water everywhere. Nary a drop to drink. There's a poem, man. This is from I Shot the Albatross. Okay. Anyone into poetry? Yeah.
I know the one you're talking about.
Yes, yes, we've heard of it.
Well, anyway. So what am I doing now? I'm doing the F test to check whether
Variance is same or not?
my variances are equal or not. Okay, so go to data analysis and the F test. I click OK. It asks you for variable range 1 and variable range 2. Okay. Remember that in the F test, this is another thing that you should remember. The first variable range 1, its standard deviation must be more than variable range 2. Okay, the population with the higher standard deviation from your sample will always be variable range 1.
It should be male then first.
Male one.
So we need to put
In which case I will choose variable range 1 as males. Okay, so my males are variable range 1. My females are variable range 2.
Excuse me, sir, I missed the point actually. I mean, on what basis we selected the male?
So I'm looking at remember we calculated the standard deviations for males and females here,
Yes.
correct?
Yes.
Based on that, I'm selecting variable range 1 and variable range 2. The higher standard deviation is always variable 1.
Okay.
So in which case my males will become variable 1, my females are becoming variable 2.
Got it. Thank you.
Okay, yeah. So I think I messed up there by selecting those. So
Yeah.
okay. I have my labels in the first row. I will check off that box and I click OK. Okay, it
So
throws
you
out
took
some
male as variance one.
variable 1.
Yes.
Yeah.
Okay.
Because
Higher.
because it had a higher variance. Okay, everybody okay with this?
Yes.
Yes.
So quick question, F-test is used to just verify if the variances are
Equal or not? Yes,
equal or not. Okay.
that is correct.
But I mean, could we just not do that with the standard deviation formula? Like,
No, hold on, Pramod. We're going backwards here. Tests are done for what? For populations, not for the sample. In this particular sample, it turns out that the variance of males is more than variance of females. But how do I know that this is true for the overall population?
okay.
Remember, every time I do a hypothesis test, what is my test predicated on? This is not for the sample. This is for mu.
Okay. Right. Yeah.
I don't know the population mean.
Got it.
Right.
Got it. Yeah.
Which is why I am testing whether the population mean is true or not. The sample values I already know. There's no uncertainty there. There's uncertainty regarding the population parameters. No, what is my statistical inference? It is about population parameters, not about sample statistics.
Got it. Yeah.
Folks, everybody clear on this point? Because it's important,
Yes.
right? So, yeah. So,
So-
what am I claiming? Sorry,
So
one second.
Revati here.
Yeah, Revati, go ahead.
Sir, I got the first 4 calculations. The F is not matching to your result, what you've got. So what did you do after choosing the range and then label?
I'll get it. 1 second. So let me just finish this point that I have, right? So what was I doing saying here? What is this test for? What is this hypothesis test? This hypothesis test is saying
Variance.
what? That sigma 1 squared is equal to
Sigma 2 squared.
sigma 2 squared. This is variance of population 1 is equal to variance of population 2. Okay, everybody, let's be very clear about this. This is not S1 squared equals S2 squared. This is incorrect. I already know the value of S1 squared and S2 squared, right?
Yeah.
What are those? I can see them in the Excel output there. What is my variance for that particular for males? 38.12. For females it is
11.8.
11.86. I already know what those values are. There's no uncertainty with respect to my sample values.
Yeah.
My test is for the population. Folks, everybody okay with this?
Yes.
Yeah. So let's be very clear what we are doing here. Okay. So this is not what we are doing. Okay. What is my alternate then? My alternate hypothesis says that sigma 1 squared is not equal to
sigma 2 squared.
Sigma 2 squared. Okay. Everybody okay with that?
Okay.
Right? Okay. Yeah. And then of course Excel is giving us this output. So then now it becomes easy. There's no calculations to be done. I have my F calculated value here.
Yeah.
Folks, everybody okay with that?
Yeah.
I have my F critical value.
F critical value is different from me. I don't know why.
For me, F calculator value is different.
So
Select
can
the
you
base
please
one.
show how we calculated F one more time? Actually, I'm getting a little confused.
Okay, so in the data analysis toolpath, I chose the F test to sample for variances, correct?
Yes, yes.
Okay, and I clicked OK.
First one male.
First one, variable range 1 was male, variable range 2 was female. I clicked alpha as 0.05 and I just said, okay, that's it.
Yes.
That's what I also did on the
Okay,
same,
alpha
but
point
my
Why?
value.
Correct.
I
So
think I chose.
You have to select the labels also.
No,
You
maybe
don't.
you missed values.
we did select labels also, I think.
Yeah.
Still values.
Maybe you missed one value, yeah. So just make sure that you select the entire data set, okay? Guys, is anybody else getting the same numbers that I have? Or did I mess up?
No, I
No,
did
it's the same.
Got the
Same.
same numbers.
same number.
Same for me as well. Fine, okay. So, but again, same thing, right? I have F calculated, I have F critical. What will you do? What is our standard test here? F calculated is
So what will be the output range selected?
whatever is for females, you select in for a male is variable range 1. That column for males is variable range 1. Column for female is variable range 2. I should have 46 observations in male and 126 observations in female.
No, like we have selected variable range 1, variable range 2 by selecting the total number of values for 1 and 2 for male and female, and then alpha is 0.05 and output range will be?
Output range is basically
where you
wherever you want the results to be published.
Just select new worksheet, no?
New
What's the
worksheet.
easiest thing to do?
New worksheet.
Yeah.
Okay. Acha, okay.
Yeah, now I'm getting. I think I swapped the variable
Okay.
1 and 2.
I get it.
Exactly.
I
So-
was not selecting the male and female that label, so that's why I was getting different.
I don't think so. It shouldn't
think-
matter.
Numbers
Yes, sir,
will be
Now
actually,
I
I
same.
was
also
selecting
did
F3 and E3. Earlier I was selecting F4 and E4. Means from F4 to F129 and E.
But still, if you, Charu, did not select
Numbers
that
are the same.
mark, still you will get the right value.
No, actually, I also didn't get the right value when I
Okay,
selected.
fine. That's okay. So we can just sort of follow this process, right? So what is our process, by the way, to reject the null?
F
The calculated value must be more than
critical value.
critical value. Is that true here?
Yes.
F calculated is
3.2.
more than F critical implies
Reject the null.
reject the null. Which means what?
It's not equal.
That they are not equal.
1 is square is equal to not. It's not equal to 6.
They are not equal. So which means that the variances of male and females are statistically different. Correct? So now with this test in place, I will go ahead to compare mu1 and mu2, or mu male is equal to mu female. To do this test, I must choose what? The t-test with
Unequal variance.
unequal variance. Right. So now I know that I must choose the t-test with unequal variance. Okay, everybody okay with that?
Yes.
Yes.
Just a small question. So,
Yeah.
why should the first one always be the one with higher variance, like when we do this? Or
Yes.
is it just like a standard?
No,
Is there a
in
reason
the
why?
F test, see, you will notice this, that in the F test, there is no two-tail,
Mhm.
right? In the output for the F test, you see a two-tail test?
No, yeah, it's only one tail.
No, you don't see a two-tail test. That is because you always want variable range 1 to have a higher, that is a requirement.
Yeah.
Okay.
Okay, so just be careful. When you do the F test, the variable with higher variance is always variable 1. The one with the lower variance is always variable 2. Okay. Revati, did that answer the question, by the way? Did you get the right output?
Yes, I did. And I
Okay.
also understood the why male and female, we had to change it because of the variance. Yeah.
Correct. Right. So do you see the values of variance here? In this output, do you see variance for male and variance for female?
Yes.
Yes.
The male is more than female, correct?
Yes.
Which is why it has to be selected as variable 1.
Okay.
But how do you determine that before even, I mean, you did this, I mean, you got the variance only after you.
No, but you
No.
can take
From
the
standard
average
deviation.
Standard deviation.
is also
I had done variance here.
a
No,
derivation of
That
variance.
one. Okay, yeah.
I knew this value here.
Got it. Yeah.
I calculate the variance of those populations first, and then I figure out whether. Remember, this is the sample variance.
Mm-hmm.
These are sample standard deviations, right? I calculate the standard deviation of that particular sample, and then I select the one with the higher as the variable range 1, and then the one with lower as variable range 2. Okay.
Perfect. Thank you. Yeah.
And once I do this, then I get the test which says that they have unequal variances. So now I'm in a position to compare mu f equals mu m. Guys, everybody okay with what we're doing here?
Yes.
Okay. So now this is my test that I want to do, right? And my alternate says that mu m is
Not equal to.
mu f. Could you have also set up the one tail?
One tail.
Yes.
If I had set up the one tail test, what would that have looked like?
Less
Mu
than.
m
Male is greater than
Mu m is what?
Less than mu f.
What is my sample?
Great.
What are my sample values of means?
45 for male and 42 for female.
Greater
So,
than.
MF is greater than M.
So then my one tail test would have
Less
said that
than M.
mu m is
Greater than
Greater than mu f.
F.
exactly right. I would have said that mu m is greater than
mu f.
mu f. Okay, everybody okay with that?
Yeah.
Okay, so let's do the two tail test. Again, how am I doing this? I go to data and data analysis, and now I am selecting.
T-test for unequal.
T-test.
Yeah, so I'm selecting the
T-test with
t-test with
unequal variances.
unequal variance. Exactly. Click OK. Variable range 1 and 2. Happen here. Hold on there. My laptop is giving me some trouble. Okay, fine. So there we go.
So now I understand. Actually, by means by selecting this data analysis, this F2 sample one, we don't need to calculate standard deviation separately. It will calculate on its own once we select the range. Everything we get.
Yeah, but in which test is this, Vatsala?
So it is for no, two sample variants. I mean
Equal or unequal?
unequal.
No, but even in the two sample for variances, you would need the sample standard deviations before. Otherwise, how will you determine which one goes as variable 1 and which one goes as variable 2? Okay. Right. So I'm doing the two sample test assuming unequal variances. What is my mean difference? What is my hypothesized mean difference? I'm saying that mu m is equal to mu f, which means that the difference between the two is equal to 0. Right. So that is my hypothesized mean difference, that is 0. I'm going to output this onto a new worksheet. And I get a result which looks like this.
Okay.
Okay, everybody okay with this?
Yes.
Are we getting
Yes.
the same output, guys?
Yes.
Yes.
That's right.
Yes. Yeah.
Are my means the same as what we calculated? My sample means?
Yes.
Yeah. Yes.
Yeah, correct. My sample means are the same as what we calculated earlier. My
The one
sample
having greater standard deviation will be always first variable.
Sorry?
Correct?
Yes.
The one having greater standard deviation will be variable 1.
In
Correct?
this test, it doesn't matter. It only matters in the F test.
Okay.
Okay, so in this test, it doesn't matter. But yeah, as a convention, you can just keep it that way. Okay.
But what is the significance of alpha? Why it is both the same? We put like 0.05.
Sorry, say that again.
Alpha.
Yeah.
That is for alpha is significance.
Confidential.
95% confidence level, you take
My
it 1 minus alpha.
5% significance.
Yeah,
5% significance.
my hypothesis test by default, Excel always assumes 95% confidence, right? And that's okay.
What we have taken for hypothesized mean difference while calculating?
0, right? Because I'm saying mu mean is mu male is equal to mu female, which means the difference between males and females is equal to 0. Right? What is my hypothesis test? My test is to do this, no? My test is what? Mu m is equal to
mu
f, which means that the difference between mu m minus mu f must be equal to 0. Okay? Right. So, are you guys getting the same output?
Yeah.
Yes.
Okay. So, what is P statistic here? What is P
Just,
calculation?
sir, just one query. When I'm selecting the labels, I'm getting different value. When I'm not selecting labels in the range,
Yes.
I'm getting different.
That is happening.
Yes.
Shouldn't happen yet.
You had
That
actually
is,
select
that is what
Shouldn't
happening
have-
actually.
The number of data, because average and mean, it all depends on total number of data. That's different.
No data. There is no data in that labels, right?
Yeah,
Label.
but
You should
still
not
it
consider
is certain.
data in the labels.
We need to.
Earlier for male, I was taking from F4 to F1.
Okay, Charu, can we stop?
it is coming
So,
out.
okay, Charu, can we stop this, please? Because this is not this thing, right? This is something clunky that's happening with Excel. Okay, so I'm going to ask you to figure this out offline. Okay.
Okay.
Right. So, what is the hypothesis test here? Do I have my T statistic, which is calculated?
Yes.
Do I have
Yes.
T critical from my two-tailed test?
Yes.
Yeah. Same logic, correct? What is my logic here?
Reject the claim.
He calculated more than
Greater than T critical.
My T calculated is
more than T critical.
Greater than T critical. Exactly right. T calculated is more than T critical. Reject.
Reject.
If you reject the null, what does that mean?
Reject the claim.
That mu m is
not equal
Not
to
equal
not
to
equal to mu m, which means that the amount of time that males and females spend on the app is
not equal.
Not equal.
is different. Exactly. Right. Sort of agrees with our averages, right? Means males are spending 45.3 minutes, females are spending only 42.14 hours. Okay. When would I have used the t-test for equal variances?
When they're
When
If
the
F calc
variance
is
is
less
zero.
than
Variance is same.
Variance is same.
Variances are the same.
variance is same.
So, for example, in this case, if this value of F critical, or rather the other way around, let's do it the other way around. So, if this value of F calculated had turned out to be, let's say, 1.23.
Yeah.
Then what would I have done? F calculated is less than
F critical.
F critical, in which place I cannot reject the,
Yeah.
Variance is equal.
sorry, I can't reject what?
The null hypothesis.
The null. If I can't reject the null, then that means that my variances must be
Same.
the same. In which case I would have used the t-test with
Equal
variance.
Variance.
Okay. Yeah.
Sir, can you repeat that once again? What you just explained now, I didn't get it fully.
No, I'm saying the reason there were two t-tests that we could have chosen, right? T-test with equal variance or t-test assuming unequal variance, right?
Yeah.
So to figure out which t-test to use, I first went and did the variance test. Right? That was the F-test.
Okay, that is mandatory to do before we come to the t-test.
Exactly, because the F-test is the one that tells us whether the variances are equal or unequal.
Okay.
Which is what we did, right? So then from this F-test, I figured out that in this case, that the variances are unequal. Which is why we went and chose the t-test assuming unequal variances.
Okay.
Right, I would have chosen the t-test assuming equal variances if the F-test had told me that they have an equal variance.
Okay.
Right? So the null hypothesis in my F-test is on the screen. The null hypothesis says that variance of 1 is equal to variance 2. If I cannot reject that, then I would have chosen t-test assuming equal variances. Okay. Guys, everybody okay with this, Broaden?
So in the output of t-test, what is the DF Like in F test, it's the degrees of freedom, I believe it's -1. In T test, how is it 56?
So
So what we're trying to say is like even if there is variance difference, but still like there are chances that our mean might fall into a place where they might be equal.
of course, what does variance have to do with mean, right? Is it possible that the means of two distributions are exactly the same, but their variances are different?
Yeah.
Is it possible or not, Deepti?
Yes, yes.
Yes, it is.
Remember that product demand example that we just saw yesterday, right?
Yeah.
Store 1, store 2, store 3, all of them had the same mean of 50.
Yes.
Right.
But their variances were very different, right? One of them had a variance of 1, the other one had a variance of 100, right?
Yes.
Yeah, right.
Right.
Correct. So is it possible that there are samples where the means are the same, but the variances are different? Absolutely, yes.
Yeah, hi sir. So you mentioned that we have to make the F test to make sure that the variances are different.
Yeah.
But the earlier sheet, we already had the standard deviation. So we already knew before the F test that the variants are different. So in that case, we can simply move to T test, or do we still have to do the F test first?
Again, Rahel, it's the same question that Prabhat asked earlier. What you
Population.
have are variances for that sample.
Sample. Yeah, it is not for population.
It's not for the population. My hypothesis tests are to check whether the population variance is equal.
Got it.
Just because my samples are showing me different variances doesn't mean that that is only true for this sample, right? So for example, in the sample that I've given you, variance of males is more than variance of female. How do you know that if I had given you a second sample that the variance of female would not be more than the variance of male?
Correct. Yes. Got it, sir. Thank you.
I can't make a conclusion based on one sample, right? I have to check whether the population follows the same logic or not.
Yep.
So fundamentally, what is changing between the Excel data of unequal variance and equal variance?
The number of degrees of freedom. There's a formula here, so
Okay.
you can. So it's the same thing that I think Tejaswini was asking, right? The number of degrees of freedom are calculated when you do see right now. What is the number of degrees of freedom? If I
N-1.
it's n-1, but
-1.
what is n here? Is it
Sample
126 or is
size.
it 46?
We don't know.
We don't know. There
Yeah.
it is n1 plus n2 minus 1. Okay, and now based on those total number of degrees of freedom, there is some calculation about like standard deviation and so on. The formulae gets complicated when you have 2 or more populations, right? So we don't need to do this by hand.
Yeah. That
Okay,
is
so
true.
let's just stick to it with the data analysis tool pack. Okay, it does it in the back end, right? Yeah, but more importantly, Rahel, is that question, is the answer clear as to why we are doing the F test?
Yes, sir. It's clear now.
Right, because I can't make my conclusions about a population based on one sample, right? I have to do the hypothesis test for the population variances being equal. Yeah, Vatsala?
Yes, sir. Actually, I have one question. It may be a little silly, but it is not getting me clear. Like we said that in one tilde test, mu can be either greater than C or mu can be less than C. So
Yeah.
on what basis do we select that we should consider it greater than C or less than C? It should
Based
be
on-
it should be based on the question's data, or is it on some other assumption?
It's based on whether your sample average is less than or greater than the claim.
Okay. That's based on the data in the question only, actually.
Of course, right? Your sample average is going to be the one that determines which side of the alternate hypothesis you want to be in. Right? In that batteries example, they are claiming 20,000 hours. Right? Your average turned out to be 19,500. What sense is there in choosing an alternate hypothesis which says that mu is more than 20,000? Right?
Get it now.
Right. So then my alternate hypothesis must say that mu is less than 20,000 because that is what your sample is supporting.
Yes. I get it
Okay.
now.
Yeah. Pramod, you had something.
No, it was along the same lines as what Vatsal asked, so I got it.
Fair enough. Yeah. Guys, broadly, is everybody okay with using data analysis to figure out the t-tests?
Yes.
This is to compare what?
Yeah.
What is the t-test
different
for?
sample tests, samples.
No.
Two
population
populations.
data. Population.
Two different populations.
Means.
What about the population am I comparing?
Variance.
The t-tests are telling me what?
Mu,
They're
mu.
comparing
Means of two.
means of populations.
Ah.
My
Yeah.
t-test tells me whether mean of population 1 is equal to mean of population 2, yes or no. Now, to
Yes.
determine whether mean of population 1 is equal to mean of population 2, I first needed to figure out whether variance of population 1 is equal to variance of population 2 or not. Correct? For that, I did the F-test.
Yes.
And based on the results of that F-test, I chose whether t-test with equal
Matching.
variance or t-test with
Unequal
Different.
variance.
unequal variance.
Everybody okay with the process?
The t-test assuming equal variance, when to use it? Like it has to be exactly equal, then only we'll go for that.
What do you mean by exactly equal, Sandeep?
The option in data analysis, t-test to sample assuming equal variance. So the variance has to be exactly equal to use that.
That is what
L should be less.
our F-test is basically should tell us that statistically the variance
I think we lost user.
We lost.
Yeah.
The call dropped.
Are you guys with me?
Yes.
Yes. Now yes.
Yeah. So I'm saying that if my F-test tells me that my two population variances are statistically the same at a 95% confidence level, then I will go ahead with that test, right?
Yeah.
Again, remember, I'm not comparing the samples variances. This is for the population variance, which I don't know.
No, understand.
Yeah. Okay, everybody okay with this? Okay, fine.
Yeah.
Now let's look at another option in data analysis. I know the t-test for equal and unequal variances. Is everybody okay with those two tests?
Yeah.
Is everybody okay with the F-test?
Yes.
Yes.
Yeah.
Okay.
Yes.
What I'm going to ask you to do is the t-test paired to sample for means. What does that mean? So when do I use this test? This test is used when it's basically what we call as an intervention. Okay, what does that mean? It means that I have a population, I test them before, then I do some intervention with them, and then I test the same population again. Okay, so think of this as like I take diabetes patients, I check their insulin levels, then I give them a medicine, and then I check the exact same people again after the medicine's effect has taken place.
Okay.
I say I give a 1 week gap and I check the exact same population. So which means what? That when I do the paired test, the size of sample 1 must be exactly equal to the size of
sample
sample
2.
2.
Yes.
I can't have unequal samples in this case.
Right.
Folks, everybody okay with when to use what?
Yes.
Yes.
Yeah.
Yeah.
Remember, when we compared t-test to sample assuming equal variance and unequal variances, I didn't care that the sample sizes for males and females were the same. That is okay. But when I use paired test, it must be the same set of individuals before intervention and after intervention.
Just not the size of the individuals, yeah.
Sorry?
Just not the size, even the individuals.
Yes. It's the exact same set of people or whatever it is that you're testing before and after.
Not only the number of people, but also the same people.
Exactly. If it is people, then it should be the same people, right? Okay, everybody okay with this? You take a classroom of students, you give them a test, you check their scores. Then you send them to coaching for 1 week and you give them another test. Okay, and then you figure out whether their scores have improved or not improved. I'm checking an intervention. Is everybody okay with this?
Yes.
When do I use it? Okay. Now
Same
what
set
is
of
happening?
data.
Same set of people. Okay. So now what is the in this particular data set? if you look at the data that has been given to us,
Different sample
Sample
size.
size is
No,
different.
women,
So
there are two
the data
samples.
for
Email.
you see
Females.
reading times post and
Post
add.
ad.
Post and add. Got it.
So now the CEO of this reading app basically says, well, females are spending too little time on the app. They want them to use the app more. So they start putting advertisements in between the news articles. So there is an article on the app, and then in between some ad will show up. Is everybody okay with that?
Yeah.
Yes.
And now what they're doing is they're testing whether the reading times for females has increased post the ad, yes or no. Same set of 126 females. They measured reading times before the ads, and then they measure reading time after the ad. This then, in which case, what test will I use? I will use the paired t-test. Is everybody okay with that?
So in some
Yes.
instances, sorry, like row number 5, it's reducing after the ad.
It's okay.
Is it
Yeah.
okay?
That's
Maybe people-
possible, no?
Why does that bother you, Pradeep? I'm not going observation by observation. People get turned off, right? I don't like ads, so I start spending lesser time.
Okay, understood.
Right? I mean, like, I can't control the behavior of every single random observation. Remember, what is a random variable? I can measure and record, but I cannot control the outcome.
Right, okay.
Right? I mean, that's perfectly okay. I cannot show consistent improvement for every single person, but on average, is it
Yes,
increasing or
absolutely.
not is the question that I'm asking, right?
Yeah.
Yeah. So, which means that now I'm going to be doing the t-test assuming, the paired to sample for. Is everybody okay with this?
Yes.
Yeah.
Okay. Again, same story. Variable range 1, variable range 2. Okay. So, what should I choose? Female and male?
No,
No,
female
female
and
reading
Ad.
post.
column H.
Exactly.
Pre-ad.
Female pre-reading with females
Post-reading.
post-reading.
PNH. Yes.
Okay. So, again.
Pre-reading would be variable 1 and post will be variable 2.
It doesn't matter
Here-
again. Okay. So, it doesn't matter. So,
Okay.
But the range should be equal for both male and female while technically
sorry.
says. I mean the range both male and female counts are different. Now while selecting the variable, we have to take the same range or like because
What do we mean by the same range? I will have the exact same number of observations because I'm comparing females to females.
oh yeah, got it.
Right?
How
Now,
do we-
the same set of 126 females before ads and after the ad. So I have
Hypothesis is that after ad, they will increase, the average reading time increases.
that is correct. So the assumption here is that it is increasing. Okay, so let's say I put the hypothesized mean difference to be equal to 0, which means what? I'm testing whether there is any
Difference or not.
effect on the ad or not. Okay, so fine. Click OK.
Here, do we not check the variances?
No, there is no variance here. What happens
It's
here?
the same set
Same
of.
set of data.
Sorry, guys, my
But
Excel is
please,
behaving weirdly.
So please help me to understand what is this hypothesis selection is the 0.
The hypothesized mean difference, I'm checking whether the reading time pre-ad is exactly equal to the reading time post-ad. Correct?
So how would it differ in other cases?
What do you mean by differ? This is basically what the
As in,
test
what
is.
would be the number in other cases? If it is
You-
not exactly.
That is what you're testing, Samir. So I could have tested whether reading time is increased by 1 minute or 2 minutes. In which case my hypothesized mean difference would have been 2.
Okay.
Correct? So I'm basically then claiming that like mu of females post-ad is 2 minutes more than mu of females pre-ad. Is everybody okay with this?
Yes.
So are we putting any value in hypothesis mean difference?
0.
0. Okay.
Okay. So what I'm doing here is the same thing. I'm checking what is my null hypothesis in this test, guys.
Reading time before add and after add is same.
Yeah.
I think mu2 minus mu1
P is
greater than
equal
0.
to
Yeah.
Post.
post. Okay. This is of course for both for females. What are you guys seeing, by the way?
Same values.
Yes, then
Sir, shouldn't the
what has
null
happened to my mean?
hypothesis be?
T critical is less than.
No, forget that. What has happened to the
it's
mean?
different.
Mean increase.
Increase.
They have increased significantly, right?
Yeah.
Post the
Sir,
add, do you guys see that the average reading time for females is much higher than it is what it was before?
Yes.
So are they spending more time on the app?
Yes.
Yes.
Yeah, definitely,
Yes.
right? Because when you're seeing an ad, maybe you click on it first when you're continuing, right? So you end up spending more time on the app on average.
Correct.
Right? Everybody okay with that?
Yes.
Sir,
Again,
I have
what
a
is the-
question.
hold on for a second. So what is the test here? T calculated as what? 7 point?
Minus 1.26.
7.2. T critical is
1.97.
1.97. T calculated more than T critical implies what?
Reject the null.
Reject the null.
Reject the claim.
Which means what?
It's not equal. The
It is
reading
not
time,
equal.
Which means
reading
that
time before pre and post are not equal.
not equal. In fact, it has increased significantly, right? You can clearly see that in the sample average. Yeah. Okay. So the ad has worked. Right? The ad has worked in increasing the amount of time that females spend on the app. Okay. Yeah.
No, but even your one-tail test is not like even there the hypothesis is failing.
Of course, it is failing. Right? Because my one-tail test would say that post is more than pre. And that is correct.
Post is more than pre.
Right,
Fine.
just calculate means can help to conclude the claims, right? Why do we need to do the hypothesis testing?
Why do I need to do a hypothesis test? Because otherwise, how will I claim? How will I check the claim that somebody is making?
Okay, the claim is for the population, while as means are only for samples, so we cannot.
Of course, exactly.
Right.
Right. I only have one sample data, right? Somebody is claiming something about the overall population. I have to be able to do a test to check that claim.
So this is the population we are seeing, right, on screen, 42 and 46.
That is for the sample. No, that is for that sample of 126 people.
Yeah.
That is not all the users on the app. The app will have millions of users.
Yeah.
What we will given is
Sir,
sample
here
data.
the null hypothesis, shouldn't it be post is greater than pre?
Yeah.
No, the null is always post equals pre.
Then alternate hypothesis should be post is greater than pre.
If you want to do the one-tail test. If you want to set up the one-tail test, then you could have said that post is greater than pre. In which case also you would have rejected, right? What is T critical for one-tail?
1.6.
1.72.
Exactly. You would have rejected the null anyways. It is, in this case,
Sir,
it's very obvious that the post is more than pre. Yeah.
Sir,
Absolutely.
in case of this pair test, we are checking the sample is the same, the scenarios are different. So therefore, our check should be that there must be some difference. Like, for example, if you take the insulin in the case that you were mentioning, before insulin, the values will be different. After the insulin, the value will be different. So
Yeah.
our null hypothesis must be that it's different, it's more or less,
An ad.
other than equal.
Because of the
Isn't it?
ad that they run. Ad. They were
You
talking
could
about
set up the null that way, in which case the hypothesized mean difference, instead of entering 0, you could have entered it as 2 minutes.
2
Let's
minutes.
say your claim was that after the ads were being shown, my reading time has gone up by 2 minutes. Let's say that's what the company claims.
Okay.
In which case your hypothesized mean difference, you would have set it as 2. Instead
So
of
that means
setting
it
it
would
as
have
0.
increased by 2.
Exactly.
And if it should be, if we say less, then it should be minus 2.
Sorry, say that
Hypothesized
again.
minus.
No. the hypothesized mean difference is always positive. So whatever is higher, you will select that as variable range 2. Whatever is lower, you will select it as variable range 1.
Okay.
Whatever it is that you want. Right? You'll have to choose your variable ranges depending on the hypothesized mean difference that you want. But the hypothesized mean difference has to be positive in Excel.
Sir?
Sorry, say that again, Ashutosh. I'm not comparing across ads, right? What am I comparing here? I have an app. People are reading news articles on the app. Think of it like India Today or like whatever Times of India. Right now, in the first scenario, they were not showing any ads. In the second scenario, they've started showing ads on the app. What do we mean by same? Same to who? Yeah. So if you use the app, if you and I use the app, then everybody gets the same thing. Right? If I open Times of India today, broadly speaking, unless you customized it or whatever, yeah. So the assumption is that everybody is getting same times, yeah. That's correct.
One question here. So
Yeah.
with the previous example, we proved that our hypothesis that the means are same, we rejected the hypothesis, right? So it's not 0. And now in this example, we are using it 0. So is it correct to use this?
Sorry, Srinath, can you mute, please? Sorry, I didn't understand. What was that? So in the previous example?
With our previous example, we rejected this hypothesis that both the means are same. So it's not 0. The difference.
No, which was the previous example that we're talking about?
The previous hypothesis which we did, where we checked, right? Mu1 and mu f are not equal. So it's not.
So that is that. No. There we were comparing males to females.
So both are different population.
Yeah.
Right. We were comparing reading time of males with reading time of females. In this case, I'm not comparing males and females. I'm comparing female to female, pre and post intervention.
So shouldn't we, before using this hypothesis, mean difference is 0, shouldn't we compare that also first? Whether
what?
Whether it is actually 0 or not, whether both the means are equal or not.
No, that was variance.
Which is exactly what we're doing now, right? This is the test that tells me whether the means of females pre and post are the same or not. Yeah, Siddharth, you had something.
Okay, got it. Yeah.
Sir, just in this formula, while calculating this hypothesis, we just put the value 0. But if in case if I had an option to put it like positive greater than 0, then this T critical P would lie less than T critical, right?
Maybe it depends on what value you want to put.
And sir, in order to calculate the exact amount of minutes, the average time has gone up. I'll again refer to the mu calculated of 2 samples. I mean, from one sample, calculate the mu population, and from the other post-add sample, calculate the mu population. Then I can say on an average, in the 95% interval, maybe 4 minutes are increased. Is that understanding correct?
Well, you're checking in this particular test, all we're saying is that the pre and post ads are not the same.
Not the same. But if
that
I want to
calculate, I can claim from this test. Now, if you want to check whether it has increased by 4 minutes, you would have to put that hypothesized mean difference to be equal to 4.
Got it.
Right, and then do another test, and then you will be able to check whether, Amshika?
Yes, so my question was actually in terms of picking the values when we have a different mean difference. For instance, now we were discussing about 2, right? Where my null hypothesis is that post is greater than pre. So in that case, how do we pick the value? Should I not pick the post value first and then my second value should be the pre?
Yeah, that's correct.
Okay, because previously I thought it was the other way around. Okay, thank you.
No, that's correct. Yeah, so variable 1 is always the higher one. Variable 2 is lower. In this case, because the difference was 0, it didn't make a difference.
Yes, yes, yeah. Thank you.
Yeah, Pramod?
So I just had two questions. One is, so if it's the same sample and something has been done on it, we've used this particular test. So for this, if we use the same procedure that we did previously by doing the F test first and then the T test, will we get the same answer?
I don't need to do it. That's what I'm saying.
Okay, it's a shortcut, but it's essentially the same.
It's not a shortcut. My populations are the same. I don't need to check whether their variances are different or not. In the previous example, I was comparing males to females, so I had to check whether the variance of male is equal to variance of female. Here I'm doing the comparison between the same set of people, right?
But the
But in
variance
this
could
case
still be
also,
different.
yeah, variance could still be different, right? Because
It's different.
It is different.
The sample variance will be different, of course, but I don't need to bother about that. Not in this case.
It does not matter for us here. That's what we're
It doesn't
saying.
matter, yeah, because at the end of it, like I'm comparing the exact same sets of people.
Yeah.
Okay.
In this
Got
case, land population remains the same. Is that so?
Sorry.
In this case, we're going to consider sample and population will remain the same. We're not going to compare it to a larger population, right? So our sample remains.
No. I have no idea what that means, Shruti. I've never said that sample and population are the same.
No. I meant in the previous one. Okay, we did. So we had a sample of 126 females and 46 males.
Yeah.
We had to find out. We did the F test and then the T test, right?
Correct.
In this case, because the samples of both the sets are same, we are trying to do just directly getting to the T test.
Exactly. That's exactly correct. Yeah, because I'm comparing the exact same set of people
Okay.
with pre and post. Yeah. Sandeep?
Yeah, so if the sample size is same and individuals are the same, then this test can be used. But
That's
let's say second situation in which second time when I go and check with the same set of people and get the observation, for some reason if I have less people, and that's going to happen in real world, how to do that? in
No,
terms of-
I can't use the test.
So in that case, do we do the F and then come back to T, or?
Yeah, probably. Yeah, that is the only alternative then.
Another way.
That
Check
is
the
correct. You can't. Then you just have to treat them like different sets of populations and then just do the F test and the T test. If you want to use the more accurate paired T test, then it has to be the same number of observations. There is no other choice.
Okay.
Right? Okay. Yeah. Come on.
Yeah, just one quick observation. Even though the hypothesis we reject, it shows that 4 minutes its average is increased. Looking at the
Yeah.
variance, can we make a statement that second case the spread is very wide?
What do you mean by second case?
Like post add, right? Because the variance from 11.8 it moved to 25.16. Does
Yeah.
it mean the spread of the time, right? Maybe anywhere
Absolutely.
between 21 minutes
Exactly.
to plus 24. Okay, thank you.
Absolutely correct. Yeah. People who like to look at the ads ended up spending more time. People who got irritated by the ads left the app.
Correct. Okay, thank you.
Right. So therefore the variability is much more now. Again, pros and cons of a business, right? You put an ad, it works both ways. On average, are they happier though?
Yeah.
That is
Yeah.
true.
Yeah, yeah. Because if the metric that you're using is average time of reading, then I'm happier. I have fewer customers, but because each of them is spending much more time on the app, my average reading time is going to go increase. Okay, my loyal customers have become more loyal. The people that were not loyal customers have just left. Okay.
So just one question here. We are assuming that the higher mean means that people are spending more time over there. I mean, considering this particular matrix. But if we look at the variance is also very high when we have the ads. So that could be a different picture, right? That maybe there are some people who are spending more time, but there are many people who are spending even lesser time.
Absolutely. Absolutely. Correct. So your distribution has changed. Yes. That's true. Right. So now that's exactly what I was explaining before, right? Like there are some people who become more loyal, right? They're spending a lot of time on the app. Whereas there are others that are spending very little time on the app. But on average, you've increased.
Correct. Yes.
The people who are spending more time on the app have compensated for the people that are spending lesser time on the app. Exactly. And therefore, on average, in fact, your time has increased by 4 minutes. Okay. Yeah. Yeah. Sarah, you had something?
So out of curiosity, like it's not concept wise, but calculation wise, I was just thinking like now let's say we have a data for male also after the ad, right? So we'll have data for male. Now is does it make sense to compare the test like what we did now? Like we got pre-ad and post-ad female, same set of sample female count.
Yeah.
Then we test it. Now we have data for male also. And is it, I mean, let's say we put the calculation, right, the data analysis, and there we put this variable male and against the female for the same paired test. Will that work?
No, no, I can't compare males and females using a paired test. My sample size must be the same. I can do pre and post for males too. That is okay.
Yeah, actually, I'm selecting the same number of cells. I'm not taking different. I mean, counts of cells are same for both male and female. I'm not taking the entire female count 128 or something. I mean, I got
No.
some, but
No. Paired t-test is for the same set of individuals. Unless something drastic happens and after you read the app, you change from a male to a female, which I think is unlikely.
So any other concept, like let's say this is
If the app has some effect on your gender, then maybe that's miraculous, but then I sincerely doubt it. So,
got it. Yeah. So that kind of test is any concept where in stats, any kind of test map to this comparison, or it is the invalid thing?
Normal t-test, no. How does it matter to you whether the sample size is the same or different? T-test, the normal t-test, assuming equal variance or unequal variances, will work anyways, right? Yeah. So just use that.
Yes.
Yeah. Fish?
Sir, I was just visualizing in the clinical trial setting, like when we are taking the laboratory values of patients before giving the drug, and then like we're taking again values after giving the medicine. Let's say we're checking for blood pressure. Can we use a similar test to assess the improvement? Whether there's
That's exactly what I'm saying. You should be using this test for. You should be using the paired t-test in that case, assuming that the exact same set of patients are being tested pre-medicine and post-medicine.
Yeah.
Right. Okay. Broadly, everybody okay with this, guys?
Yes.
So now you have some tools in your arsenal, right?
Yes.
Yes. You can now start to actually look at data, figure out whether claims are the same, not the same, so on and so forth. Okay. So, by the way, yeah.
So in the ad case only, so for example, the ads are targeted for male. If that is the case, then we need to see whether the reading time is more now for male readers versus female readers when the target is male. And then when you change the ad to target the female, so that kind of comparison also we can do by paired comparison, is it? Is it true?
I don't think so. Unless like there is a mechanism for us to, how would I know if someone logs into the app? Imagine that you've developed an app and someone logs in, right? Unless the ads are targeted, if you know who is the person reading, and then based on whether it is a female reader or a male reader, if my ads are changing, only then, right?
Yeah, assuming males are logging in with their own ID and reading through their
Yeah, but
ID.
I'm saying, see, if you download an app on your phone, right, the ads I don't think are customized based on gender.
No, I'm saying that ads that I'm posting as a business owner, if it is targeted for males, and if I want to see after posting the ads, if the male reading time increasing or not, and if I want to compare that study towards to the reading time difference for female readers, I can do that by doing the pair study for male first and then pair study for
Sure.
female?
That's fine. Sure.
Okay.
Absolutely. Yeah. If your target audiences can be identified early and so on, yes.
Okay. Okay. Got it. Thank
I
you.
mean, if the ad, let's say, is, pick a magazine that is mostly tailored to men, right? Men's Health, for example, is a magazine, right? Is an app. If I'm reading Men's Health, then of course I'm going to assume that look that I'll be able to measure the reading time for males, right? I mean, like I'm assuming that female audiences will not be reading Men's Health.
Yeah.
But otherwise, if it's a generic app, I'm just looking
Generic
at
app.
how you would do it. Times of India, for example, yeah. How would they know who is reading? How would they post an ad that is specific for males versus females?
Yeah, that is the question. I mean, which kind of ad should I post in my generic app? That was my hypothesis. So
Yeah, fine, you're deviating. Yeah.
understood. Yeah. Thank you.
Is anybody else? Are we broadly okay with what we are learning? Is everybody okay with the notion of using these tests?
Yes. Yes.
Yes. Yes.
Okay, cool. All right, take a quick 15-minute break. Come back at 12:10.
Sure.
And then we'll do some more. Okay, cool.
Okay.
All right.
Yes, please.
Cool.
Thank you.
Recording stopped.